back to our YouTube channel. Today we are going to solve question number 7 on our list of 17 questions for differential equation major exam at the University of Liberia. And we have number 7 that says tangent to a curve intersect the y-axis at a point P. So we have a curve in the Cartesian plane, and we have a tangent to that curve intersecting the y-axis at a point P. Now, a line perpendicular to this tangent, so there's a line that is perpendicular to that tangent line, through P, passes through A, which is 1, 0. What is the differential equation of the curve? Question mark. So to solve this problem, we must firstly visualize the entire problem in terms of the curve and the point P and the point A and so on. So let's draw a picture of what we're talking about. So you have the Cartesian plane like this. Point on this y-axis at which the tangent intersects the curve. So let's try to draw the curve. So we'll say the curve is something like maybe a parabola, and then there's a tangent to this curve. So the tangent goes like this. This is the tangent to the curve. And this is a point. This point is point P. So point P will have coordinates 0, y. So 0 meaning there is no x value here, and y meaning now we are told that a line perpendicular to this tangent, so there's a line that is perpendicular to this tangent, through P, passes through A, which is 1, 0. So 1, 0 is right here. At this point, x is 1, y is 0. So we are told that tangent, well, we are told that a line perpendicular to this curve, so this is the line that is perpendicular to the curve. It passes through P and also passes through the point. This is the point 1, 0. So this is the line. And this is point A. Point A is 1, 0. So we have the point P, we have the point A, 1, 0, and then we are told to find the differential equation of this curve. Great. So to find the differential equation of this curve, we must firstly begin with the equation of a line, because obviously there is a line, and we must firstly begin with the equation of a line. Y minus y naught is equal to m parentheses over x minus x naught. Now, once we have that, we will realize automatically that this m is the slope of the tangent line to this curve. That is the definition of m. M is the slope, but the slope of the tangent line to the curve. So the m is the derivative with respect to x. So m equals y prime, which is the same as dy by dx. So this m is y prime, or you can replace that with dy by dx, any one of them. Now at the particular point P, so say at P, at the point P, we know that x is 0 and y is some y, right? So point P we have x will be 0 and y will be some value of y. So if we take these and replace them in here, we have minus y naught is equals to m is y prime, which is the slope, y. So at this point now x is 0, 0 minus x naught. What is x naught? X naught is just x naught. So y minus y naught is equal to the slope. M is y prime, parentheses open x. At this point x is 0. So it's x minus x naught. So we want to find the coordinate of this point P, defining y. So y minus y naught is equal to, so this is y prime onto 0 minus x naught is negative x naught. So y minus y naught equal to minus x naught y prime. That's what you have. Now you can solve for y by sending y naught across. So you have y is equals to y naught becomes positive minus x naught y prime. So the coordinate of P is, so x is 0 and y is y naught minus x naught y prime. This is the coordinate of P. So we can find the slope of this perpendicular line. So it's a slope of perpendicular line. To find the slope of this perpendicular line, we know the equation to be the slope m is equals to y2 minus y1 all over x2 minus x1. So in this equation, y2 is just y and y1 is y naught for this particular point. So y2 is y and y1 is y naught. So y minus y naught over x minus x naught. But remember that the slope of this line is a negative reciprocal of this slope of this other line. So since this slope is y prime, the negative reciprocal of y prime is negative 1 over y prime. So this m is negative 1 over y prime is equals to this y is defined as this. So we replace this for y. That's y naught minus x naught y prime all divided by x. What is x? At this point x is 0 minus x naught is 1. That's all we have. If we have that, we can go right ahead to erase this side. Great. So once we have that, we can go and rewrite minus 1 over y prime is equals to, now this y naught is just a y value. So to find the differential equation of the curve, that will be just y. So y naught is just y minus x naught is just x naught. So this is x, y prime, all divided by 0 minus 1 is negative 1. So we can go and cross multiply. This time this is 1 equals y prime times y minus x y prime. So 1 is equals to, this time this y prime, this time this minus x y prime all squared. This one first and bringing this one second, that is very same thing. So we have y prime minus x y prime all squared equal to 1. And this, ladies and gentlemen, is the equation of the curve described in the problem there. Thank you and see you soon.